Welcome to today's session. In today's session, let us continue with 8051 delay calculation. 8051 calculations are mainly affected with two factors. First one, crystal frequency and make of 8051. Okay, that is, in the crystal frequency, the duration of the clock period, it indicated for the machine cycle, and it is a function of crystal. For the second one, 8051, as we know, the original machine cycle duration was set at 12 clocks. And the coming advancement in technology, that is the IC technology, this machine cycle clock has been reduced. Means the particularly one machine cycle we told consists of 12 clocks. It is consuming a more time. Nowadays, the advancement or a technique has been improved such that it will be reduced. As we can see in a table, there are 4 makers we have given. 80, that is a Atmel 89C51, it will be consuming 12 machine cycles. It is quite a more. And later 89C X2, that is made by Philips, consuming 6 machine cycles for one machine cycle. That is a 6 clocks. And later there is a Dallas with a series of DS5000 will be 4 machine cycles. And similarly, the improvement in Dallas given with 1 machine cycles means, obviously the previously what we have taken, 1 machine cycle is equal to 12 clocks. That is a quite high. When you see the fourth one, it is just consuming 1 machine cycle is equal to 1 clock. Means my execution rate will be getting increased. So the instruction running very fastly. I hope you understood. Let us take with a simple example to find clock period for the given 4 makes. Find the period of machine cycle for various versions of 8051. Look at there. I will maintain the same crystal frequency, that is 11.0592. And I need to calculate the duration of each machine cycle. As we know here from the previous table, Atmel 12, 6, 4 and 1. As we know, in previous class I given with the equation to calculate TINST is equal to C into 12 divided by frequency. Now this is a 12, it is for 8051. Now if it is for the different make, this 12 will be changing. So for 89C51 it will be 12. Now for X2 it will be different. For DS500 that will be different, and CX40 this will be different here. Means it will be consuming 12. Look at here, 12. For 89C5X2 it will be 6 clocks. Means instead of 12 we have to make it a 6. For 500 it will be 4. This will be, instead of 12 it will make us 4. For the last one, DS89CX0, it will be 1. Means I will get here different timing cycle. Look at here, the very first one, 1085 nanosecond, quite a large. It is just 90 nanoseconds. Means it is a much faster. Let us take with one more example related to the switch. A switch is connected to pin 1.7. Write a program to check the status of switch. SW stands for switch, and perform the following. If switch is equal to 0 and send letter P2, okay, send a letter N to the P2 port. If switch is 1, okay, send letter Y to the port P2. Means P2 will be set with N or S, depends on switch. If this switch is 0, that is then N will be set. If this is 1, Y will be set. Okay, look at here, my input will be coming from port 1, that will be 7th bit. Okay, now set B. Okay, I hope you know that set B means it will set the port P1. Okay, B for bit means it is setting a particular bit of the port P1. Which bit? 7th bit. That is a 8th bit of that. Okay, now check it. Now the next instruction is JB. J stands for jump, B stands for bit. Jump if bit. Which bit? That is, this is instead of like 1.2, you read it as a 1.7. 1.7. Okay, jump bit. Jump if bit. Which bit? 1.7. If bit means what? If it is 1. If it is 1, where it will go? It will go to over. Okay, what I said here? Now, what to set here in port P2? It has to be set with Y. Means Y. Okay, this is what, okay, I hope you can understand. There's a hash means is the immediate. If I include with a single quote, okay, is a character. Y is a character, it will be copied into port P2. Means Y will be copied into where? Port P2 as per my statement. When it is happening? When the bit is set. Which bit is set? P1.7 bit is set. If not, okay, jump if bit means P1.7 is equal to 0. Means what? Jump if bit. Which bit? P1.6. No. Then this become a false. It won't go to the over. Where it will go? It will go to the next instruction. What is the next instruction? Move P2, hash. N. N is again a character. If it is a character string, it has to be included. Okay, it has to be enclosed within single quotes, and it will be copied into port P2. Okay, I hope you understood. The port will be set depends on the input coming from the port number 1.7. This is what the program. Okay, let us take with one more program. Again, a switch is connected to port to pin 1.7. Write a program to check the status of switch and perform the following. Okay, when I say performing the following, what is that? Same here. Okay, as per the previous statement, only the modification is that use the carry flag to check the status. I am checking the status by using carry flag. As we know, okay, as per my previous one, again this one you take as a 1.7, okay, because my input is coming from 1.7. okay, set B, make P1.7 an input port. If I set 1, it is input port. Okay, now move, okay, C, 1.7. okay, now what is that here? Read switch status into carry flag. Let us take, okay, what I told, my switch, let us assume that there is a switch. There is a switch. It is connected to port number 1.7 like this. If this is on, okay, open, if it is open means 0, if it is on means, okay, 1. Let us assume that it is on. I made it on. Means what signal is generated? 1 is generated. Where it is generated? it is generated in which port? Port P1. Which bit? That is 8th bit, that is P1.7. Now assume that whatever the status is there, that will be copied into C. Now what happens here in this matter? My switch is on, 1 is copied into carry. Now carry will be holding with 1. Jump on carry, is it true? Yes. Where it will go? It will go to the over labeled instruction, there in which Y will be copied into which port? Port P2. Okay, I hope you understood. Okay, let us assume, okay, in the second way, the switch is open. Switch is open. Okay, I'll come to this point. Now port P1, 8th bit is active. Switch is open. Open means what? Instead of this 1, I'll get a 0. Okay, now what is the content of 1.7? 0. It will be copied into where? Carry. Now carry is holding what? 0. Okay, jump on carry, it is not true. Okay, then where it will go? It will go to this next line instruction. What is there? N is character. N is the character. Where it will be copied? It is copied into port P2. Okay, I hope you understood how the execution here. Okay, just I'm using a carry flag to check the switch status. Okay, there is another program. Okay, a switch is connected to pin number 1.7. Okay, let us take again. I'll take here switch. Okay, I'll take a better way. I have a switch. Okay, this is my switch. Okay, now where it is connected? It is connected to P1.0, means my data status will be reading from P1.0, and an LED to pin P2.7. Okay, means LED is connected to which port? Port P2. Which bit? That is the 8th bit. That is a P2.7. Write a program to get the status of the switch and send it to the LED. Whatever it is, that will be sent it to the LED. Means now this is my switch. Okay, it is connected where now? That is P1.7. Okay, now look at here. Set B means port P1.7 is active. Let us assume, okay, read switch status into carry flag. Means whatever, if I read whatever the content, look at here, whatever the content will be there. Okay, now if I enabled, okay, if I enable the switch, okay, here instead of this P1.7 it will be P1.0. sorry for this. Okay, now if the switch is on, it means what the bit here get here? 1. Where it will be copied? It will be copied into carry flag. Carry will be set with 1. Okay, now carry, content of carry. Now if the switch is on, now LED, okay, there is a LED will be there. LED, it is connected to which port? That is port P2.7. 1 bit. When this will be on? When the switch is on. Okay, means what? What is the content of carry now? 1. Where it will be copied? It is copied into P2.7. Means LED will be glows. Okay, assume that, okay, switch is off. Now what is the content of P1.0? Because now my switch is connected to which pin? That is port P1. Which bit? 0th bit. Now switch is off. Is what will be reading here? 0 will be reading in this line. 0 will be reading. Then where it is copied? it is copied into C. Means what is the content of carry now? That is 0. 0 will be copied into port P2.7. That is the 8th bit of port P2. What is connected in this point? LED is connected. Means my LED will be off. Okay. The very important here what we are given. Okay. Here move port to port we can't copy. I understood. Bit by bit port we can't copy. This type of instruction is not supported. Look at here. Look at here. Move P2.7 comma P1.0 means P1 point, there is a 1 bit. We can't copy into the one more bit. Bit to bit transfer is not possible. But the very important is that byte by byte data transmission is possible. Means we can transfer a data, okay, 8 bit of data can be transferred into 8 bit of one more destination port. Means look at here, P2 comma P1. P1 is 8 bit now, P2 is 8 bit, we can do. But P2.2 some number, P1.1 1 bit you can't copy. Okay, bit by bit copy is not possible, byte by byte it is possible. Okay, let us assume, let us go with this one more program. Assume that bit P2.2 is used to control an outdoor light and bit P2 point, okay, port P2.5 a light inside building. Okay, that is what P2.2, okay, that is used to control outdoor light. O, I say P2.5 that is inside the building. I say I. Depends. Show how to turn on the outside light and turn off inside light. Okay, I hope understood. How should I turn on my P2.2, P2.5? Okay, that is off. Now set B with carry. Carry will be set to 1. Okay, now when this carry is set to 1, what is the content of CY is 1. Okay, look at this. In the next one, ORL is nothing but OR with logical OR, single bit OR. Let us assume, okay, let us assume that P2.1, this is a outside light. I'll make it 1. Okay, what the bit is coming? 1. Okay, what is the carry here? 1. Or 1 or 1. 1 plus 1. What do you get here? 1. Means what the means my result will be copied into carry itself. Now what will be there? Carry will be copied into where it is P2.2. Means turn it on if not on. Means if it is not on, you turn it on. Okay, that is P2.1 will be set to 1. Okay, now clear the carry. What is the content of carry? Previously it was holding 1. Clear it. Means it becomes 0. Okay. Now P2.5, that is an inside light. Inside light, okay. Assume that inside light I'll make it with the 1. 1 means it is on now. Okay. Now there's a condition given in the program that outside light if it is on, inside light you have to switch it off. When you switch it, when it is on. Okay, you can't, if already switched off, you can't switch it off now. Okay, that's why if it means assume that it is already 1. Okay, clear with C. Okay, clear with C means what here? 0. Now assume that P2.5 is on, means inside light is on. You take it as 1, and here A and L means and 0 into 1, 0, where it will be copied P2.5, and what will happen here? The content of carry, that will be 0, that will be copied into P2.5, it is turned off. Okay, I hope you understood. I'll repeat the program. P2.2 outside light, P2.5 that is inside light. When inside light is turned on, outside light. Okay, sorry, when outside light is turned on, inside light has to be turned off. Okay, how it will be controlled depends on bit flowing from the particular port. Which port? P2. Which bits? 0.2, 0.5. Means 0.2 if it is 1 or here or with a carry, it will be getting on. Okay, that is outside lights are on. Okay, if inside light is already on, okay, you have to turn it off. This is what the program. Okay, I hope you understood this program. Okay, in coming hour we'll see with some more examples related to this.